Hello, good evening, everyone. I am Mehak Tiwari, and I welcome you to the event organized by the Instrument Society of India. Nowadays, IoT and machine learning are eye-catching concepts and works parallelly with the instrumentation industry. Thus, we at ISI presents this session, which will be conducted by our guest speaker, who is the founder of Appleton Innovations and IIT Bombay alumni, leading the technology roadmap definition and its implementation for the company. He has trained more than 10,000 students on Internet of Things and data sciences. So this event will be focusing on IoT and ML concepts. Now, I would like to take the event forward and ask our speaker, Mr. Bapuji Kanaparthi, to come and enlighten us.
Yeah, hi. Mahesh Tiwari. Yeah, good evening and thank you for giving me this opportunity to be with you all. Thank you all, and I thank Instrumentation Society of India VIT branch. This is the branch of VIT, right? Okay, right. So thank you, and I thank Prajwal as well because he's the one who contacted me. So thank you, Prajwal. So I'll be sharing my screen. Can you hear my voice, everyone? Yeah, Mahesh.
Yes,
Mahesh,
sir.
yeah.
Yes, sir.
Right. So can you see my screen now?
Yes, sir, we can.
Right. So all of you, I welcome you for this session on IoT and ML Odyssey. Okay. So this session is basically on what we can design and develop using IoT and ML together. Okay. So you might be hearing about IoT, okay, and machine learning. So now I'll be explaining you how we can combine IoT and machine learning together to build more intelligent, smart devices. Okay, so that's the goal of today's program, and I'll give you basic introduction to IoT and also machine learning, so that you will understand when we combine IoT and ML how well we can design a smart and intelligent devices. Okay, so basically I'll be introducing myself already. Mahek, already introduced about me. So basically I run three things. One is Appleton Innovations for training and research. And we have another organization for product development. So we design and develop IoT products. And we have our own edutech platform called as iLead.AppletonInnovations.com. This is our edutech platform. So we are doing three things like training, research, product development, and services, and edutech platform as well. Okay. So Hubits is our actual trademark for product development. Okay, so my background actually basically BTech Electronics and Instrumentation. So I belong to instrumentation in bachelor's, and then in masters I did in IIT Bombay, basically in electrical. Okay, so these are my background, education background. So later on I worked with various organizations, and I have more than 10 years of experience in product design and development, as well in research and training. Okay, so these are the some research products we are currently working on. Okay, we continuously invest time in research and training. Okay, right. So now why we need to learn AIoT? I call it as AIoT. Artificial intelligence of things. Generally, the combination of IoT and ML, we can call it as artificial intelligence of things. There are many AIoT products in the market. One example is Nest thermostat. So here you can see the product. Actually, this is Google's product, Nest thermostat. So you can heat your room, or you can cool your room by using this Nest thermostat. Okay, this is actually a product containing both IoT and ML concepts together. So what is the use of this product? Okay, why they designed this product? And this is the most used product in USA in home devices, home IoT devices. This is the one most used product. Okay, why people used it mostly in many countries? Okay, there is a reason. So the reason is you can actually teach this particular device. So this is an IoT device for controlling temperature in the homes. You can attach this to control the heater temperature, or you can attach this to the air conditioner to cool the room. So it can help you to heat as well as to cool. Okay, there are two things you can do: heating and cooling. Okay, so with this device, what you can do is you can teach how you want to control the temperature of the room. Okay, for example, without human intervention, you want this thermostat to keep temperatures of your interest. Okay, so to do that, what you have to do is generally you have to train it, right? Suppose you have a servant, and suppose you are a master, okay, master in the home, and generally you'll be instructing the servant. Okay, so every day at 9 a.m. I want this temperature. So the servant always keeps that temperature for you, and the master asks, okay, in the afternoon on Tuesday I want this temperature. On Friday evening during the dinner time, I want this temperature. So the master always asks servant to keep the temperature, suppose. And servant, after 1 month or after 15 days, the servant remembers, okay, the interest of the master. Okay, the servant knows at what time the master requires a particular temperature. So that particular temperature the servant knows. So based on that, the servant automatically adjusts the temperature without command of a master. Okay, so it happens, right? Because servant already learned the interest of the master within 30 days. After 30 days, servant can automatically adjust temperatures based on the master's interest. Same way, this is easy thing to train a servant, right? Servant is a human being, master is a human being. So human being trains a human being. It is easy process. But now here the idea is how to train a machine. This is a machine. And here the trainer is, you or me. So you want to train, or maybe I'll be training this particular thermostat. Okay, so to train this, there must be some, learning should happen. Okay, there must be some teaching. Okay, so how we are going to teach this machine? Okay, to teach this, we need a machine learning, because humans can learn. Okay, but how machines can learn? Okay, we need to learn how to teach the machines. Okay, the way how we teach machines is simply the machine learning. Okay, so the machine learning, there are many things in machine learning. We'll be discussing about it. Okay, the first step is adjusting. So when you buy a thermostat, for suppose you purchase it for cooling, what you do is you'll be adjusting the temperatures. So for example, you'll be keeping every day maybe at 9 o'clock 25 degrees centigrade in the morning, and in the evening you are keeping in the afternoon 15, in the night you will be keeping 30 or some temperatures. You are following some patterns. So basically you have to adjust temperatures. Okay, you'll be having some facility. Okay, so there might be some knob to control these temperatures. You can adjust the temperatures by that manually. So you'll be doing that manually, but this machine will learn whenever you do adjustment manually, the machine stores the data, it stores the time, it stores the temperature value, again time and day, temperature value, time and day. So every time you adjust, it stores the time, date, and temperature values. And based on these values, okay, so these are data. Your device will be using to learn. Okay, generally we use data to teach the machines. Okay, here this particular thermostat needs some data, okay, to learn. So machines, people, okay, everyone learns only from the data. Okay, so here we are generating data, maybe for initially 7 days or 1 month. So after generating this data, now the machine starts building a model, machine learning model. Once it gets the machine learning model, now it knows everything about us. Okay, at particular day and time, we want this temperature, so automatically it predicts it. Okay, so if you give input date and time, day and time, automatically your machine understands and predicts the temperature output. So my master wants 28 degrees centigrade. So it adjusts. Okay, just you have to give the input. Automatically it takes the input because it will be having a RTC or network time syncing will be available. So automatically it gets the date and time based on date and time. So it takes date and time. Based on date and time, it has to adjust the temperature, and this temperature should be in line with our interest. If it is in line with our interest, the machine learned very well. Okay, the accuracy is good. Okay, so this is called as adapting. Once learns, it starts adapting with higher accuracies. Okay, this is how generally smart devices works. Smart devices, works, autonomously, and they generally follows us. Okay, so they are, very good for making, everything smarter so that you can reduce the energy consumption. Okay, so because the machine knows about our requirement, so it adjusts according to that so that you can reduce the energy, right? So for example, reducing heating or increasing temperatures or decreasing temperatures, it's all about maintaining some controlled atmosphere. To maintain controlled atmosphere, you are spending some energy, right? So electrical energy maybe. So that electrical energy, saving that energy is also important, right? It can save energy bills. Okay, so it can save energy bill for you, right? So that's the advantage of smart devices. So generally devices are not smart. Basically, we have to make smart by using IoT and machine learning. Okay, so now I'll be discussing with you what exactly a IoT and ML device. Okay, or what is artificial intelligence of things. So artificial intelligence of things are smarter products, okay, are designed by combining two important concepts. Some of you have some brighter thoughts, ideas. Okay, suppose with us we have many students right now. So I think Prajwal and he invited many. I think Instrumentation Society invited many students, and you joined here with some thoughts, right? You want to do some good, device. You want to design or you want to innovate some product. Okay, so you have some things in your mind, but so how to design such products? See, always remember, designing a product is okay, but designing intelligent products requires several skills. Okay, so one such skill is IoT, another one is ML. So the power of ML and IoT together can help you to build products. Okay, so suppose anyone is having any ideas here, product ideas. If you have any product ideas, suppose you want to build some product. Anyone?
Yes, sir. Yes, sir.
Right. Okay. So Prajwal saying you have some idea. Okay, right. So what is your idea?
Sir, like if we want to, if we are going out from our house and we want to protect our house from encryption, so we can type a lock in such a way that we send a SMS or something like that. So only we can open the door or close the door.
Okay. So you want to open or close the door based on what is the trigger you are providing?
Sir, like we send an SMS.
Okay, you are sending an SMS.
Sir, imagine like you are in abroad and like you have given this room to your servant.
Okay.
And like there is one particular room that you want that no one can open it.
Okay.
So you can send the SMS and then only that person can then they can access the room.
Okay, good. Okay, nice idea. Okay, so it's actually IoT based idea. Okay, so yeah, you can add intelligence to it. Okay, you can make it more smarter. How we can make it more smarter, Prajwal? Can we make it more smarter? How you know that your servant is there to open or somebody is there? How to detect
using
it?
voice modules or something like that.
Right. Yeah, very good. By using voice, or you can use like face detection. Okay, for example, if you are using face detection, you have to use deep learning algorithms. It's a part of machine learning. Okay, face recognition. Okay, for example, you want to know whether the person is a servant or not. You want to know about it. So to know about it, you need to do face recognition. Okay, so adding face recognition capabilities to your door is another important aspect. Okay, you can do that. Is that clear? Right. Okay, so some of you have good ideas. Okay, so having those ideas is good. Okay, so remember, when you want to design IoT or smarter world, remember smarter world, IoT alone is not smart. Remember, many people think that IoT is smart. Okay, controlling home appliances by using mobile application is not smart. Okay, in reality, okay, it's also following commands, right? When you say on command from your mobile app, the light will be on. Okay, if you send off command, the light will be off. But what is smartness in that? Okay, so remember, because I teach IoT, okay, basically in IoT I teach these things only, controlling things, or monitoring things. But we can do more than that. We can do more than that. Okay, so what we can do, how we can design smarter world by using ML and IoT. So I'll be discussing about it, all of you. So first we need to know what is IoT, and then how we can design IoT products, and then later on I'll show you IoT and ML. So remember, IoT and ML, these two are two training technologies. We know about it. Okay, so basically these figures indicates that salaries are also too high in these two domains, IoT and machine learning, or you can say data science. People call it as data science because data science contains all this machine learning, AI, deep learning. Okay, so these are all different domains generally existing in data science. Okay, so there are many opportunities for students in both IoT and machine learning. So you may be building some projects, okay, or you may be building some products on your own. Okay, basically some of you are from instrumentation, some of you are from electrical engineering, or some of you are from electronics and communication engineering. So maybe your background can be anything, but remember, so instrumentation engineers generally works in sensor part. Basically they learn in their curriculum sensors part, embedded system design part, and everything. But you need to learn more than that. Okay, so you need to learn networking, cloud, application development. So all this comes in IoT. Okay, so electrical also can work in this particular domain, CSE, electronics communications, because this is not just specific to one domain. IoT and ML is basically it's an interdisciplinary program. Okay, so where you have to learn different technologies together to design the IoT product or machine learning part. So if you are choosing some field here, so suppose some of your students are choosing IoT and ML together, so that's the best choice for you. If you're choosing IoT plus data science or data science plus IoT, so I say that you are going to get good opportunities in the future, because this is only the future. In India, abroad, USA, how many of you know that Biden statement recently, 1 month back, Biden gave a statement. Okay, so he says that those who are doing MS in data science, okay, he said that he's going to extend, visa for 3 years more. Okay, so only those who are doing MS in data science, maybe in the near future, you may be getting more opportunities if you're doing in IoT, machine learning, data science. Okay, so there are several opportunities in USA and other countries, right, all of you? So what is IoT? What is Internet of Things? Okay, so I have given a simple diagram of what is Internet of Things. Okay, so I'll be defining what is Internet of Things. So to define Internet of Things, okay, just understand Internet of Things is two things. Okay, so Internet plus things, is that correct? No. Okay, so Internet plus things is not correct. Okay, so Internet of Things is all about connecting a thing. For example, you have a thing and you want to make this thing to speak or to talk. Okay, so how to make a thing speak? How to make a thing to talk? General things are dumb things, right? So things are dumb things. They cannot talk. Okay, they cannot even think. Okay, so they cannot sense also. They don't know. They don't have senses generally. Things. Okay, examples: chair, table, water bottle, or you can take another door. Okay, all these are things, but those are non-living things, dumb things. Okay, the idea of IoT concept is how to add smartness to these things so that these things can talk, these things can speak, these things can think. Okay, that is a basic idea. And at the same time, you can do remote controlling, remote monitoring. Okay, there are many other things we can do, but in reality, okay, making things smart. Okay, for making things smart, how we can do that? Take a simple example. Okay, take a simple example. Suppose you have here a simple machine. Suppose you have a CNC machine. CNC machine. CNC, for maybe for cutting. Okay, you have a CNC machine for cutting. Or better example, I think it is better because some of you are from instrumentation and electronics. So take a simple example here, water bottle. Okay, so water bottle example. Suppose you want to make a water bottle to speak with you. Okay, so suppose some of you are hard workers and smart workers here. Some of you used to forget time. How many of you generally forget time drinking water, or sitting for long hours? Okay, how many of you experience this when you're studying or when you're doing some job? Okay, so I know that most of you do this. Okay, maybe when you're playing game, or when you're playing studying something, or when you're seeing something, you generally forget to drink water. How many of you do this? So I do this. Okay, it's me. Okay, because I used to forget. Okay, many of you generally do this. Mostly engineers who work with softwares, those who work with hardware continuously in the laboratories. Yeah, so they generally face this issue. Okay, so I too face the issue, right? In such case, what we have to do is, so now you want to design a smart water bottle. You want a smart water bottle. This smart water bottle has to send notifications to you. Notifications to your mobile phone. Maybe the notifications can be push notification, or the notification can be SMS notification or WhatsApp notification. Some notification you want to receive from your water bottle. Okay, so this water bottle, generally measures. So you want to add, some measuring capabilities. Okay, so you are from instrumentation, so sensors, right? So we want to use a sensor to measure the amount of water that you are consuming. Okay, the amount of water that you are drinking. Okay, so for example, 1 liter. So your target is suppose 5 liters per day. Okay, so already 75% of the day completed. So it is in the evening 6 p.m. But you drank only 1 liter. Okay, now this particular water bottle generally starts reminders because it has a time limit, like morning 9 started at 6 a.m. suppose, and it goes up to your sleep time, for example 9 p.m. So 6 a.m. to 9 p.m. it will be measuring. It divides every timeline into 5 liters, like 1 liter, 1 liter, 1 liter, 1 liter. So for time duration, it checks whether you drank 1 liter or not. If you did not drink 1 liter, then automatically it sends a notification to your smartphone. Okay, for designing such a product, what do you need? First step is, you have to measure water, consumption, how much water you're drinking. Okay, so to measure that, you need sensors, and you have to interface sensors with a microcontroller or a microprocessor. Okay, so locally you are measuring water consumption. So sensor can be some water flow based sensor, or it can be some ultrasonic based sensor. So you may be using some sensor for measuring water content. Okay, so water, total amount of water consumed. So sensor plus microcontroller plus microprocessor, because sensor is just a electronic device. It doesn't know anything. Okay, so it gives generally change in physical quantity. We know what is sensor, right? Sensor input is physical quantity, and generally it produces some electrical signal or some other form of energy, right? So we know that. Okay, now we have to read the signal in the controller, microcontroller or microprocessor. So you have to interface sensor with the microcontroller or microprocessor. Maybe during the interfacing, you need to use some processing circuit also. You need to design some processing circuit as well. Okay, that you have to do. And along with that, now you have to write a program in this microcontroller. Generally, the program that you write in the controller is called as firmware development. The software that you write inside of the microcontroller is called as firmware. So you need to write a firmware. So most of you know, how many of you know here Arduino here? I'm not able to see the chat box, but you can just say yes by unmuting. How many of you know Arduino here? Arduino programming.
Yes, sir.
Right.
Yes.
So yeah, generally what you do is, thank you so much. Okay, thank you. So most of you know it, right? So generally you write, program in Arduino, maybe generally C++ syntax program, and you'll be uploading that program to some microcontroller. You can use some ATML controller or ESP based, or maybe it supports many microcontrollers. So you'll be uploading that program into the controller. Okay, once you upload the program into the controller, then it starts measuring data locally, and controller captures or collects the data from the sensor. Now the data is available in the controller. Okay, now we have to send this. You have to process. First you have to process. After processing, you have to send this data to the app, right? The best way is not to send directly into the app. Okay, always remember. Best way is not to send data from this device to the app. So there are two kinds of devices generally. Some devices sends data from directly from sensors or microcontroller to app by using Bluetooth. Okay, that is one way. Other way is using Wi-Fi. So now to transfer data from here, okay, that is from edge device. This is called as edge computing. So edge device, okay, where you have sensors and everything, microcontroller and microprocessor. So you are collecting data locally. After collecting data, you have to send this data to the app or cloud. To do that, you have to connect this to the network. Okay, so network. So node design is all about, remember all this is called as node design. Interfacing sensors plus microcontroller plus circuit, some interfacing circuit plus to connect to the network. So what do you need? Okay, so network, maybe there are different types of networks, right? Now you are using a network, right? What is the network you are using now? You may be using Wi-Fi network, or maybe you are using some Ethernet network. Okay, maybe some of you are using cellular network. Okay, so there are different types of networks. Okay, so we use, okay, so you can use any network. So there are short range, long range based communication technologies available. So we can use Wi-Fi, Bluetooth, or cellular, or long distance like LoRa, Sigfox, or you can use Zigbee. There are many communication technologies. The choice of communication technology depends on your application or use case. Okay, how far you want to transfer data, what is the data rate, like you want to transfer large amounts of data or small amounts of data. Okay, based on that, you have to choose the communication technology. Okay, once you choose the communication technology, so is communication technology software or hardware? Anyone tell me, is that software or hardware?
It is embedded.
Right. So generally, when you are working with a communication technology, basically, what you have to do is you have to get some module. Okay, so that's a hardware module, and the hardware modules can be Wi-Fi module, or it can be a Bluetooth module, or a LoRa module, or maybe it's some other modules. But those modules generally don't contain a microcontroller. Okay, so but you have to interface that module with your microcontroller. Okay, so you have to interface them with the controller, and you have to initialize it by writing program in this controller. Okay, so you need to add some hardware module here, some communication module here, maybe that is Wi-Fi or Bluetooth, and you have to write initializations. Okay, for example, Wi-Fi, then you have to start communication by using SSID and password. Okay, and it should support TCP/IP. Okay, generally there are boards which supports Wi-Fi communication, TCP/IP. Okay, you have to see if it is Bluetooth. Okay, it should work with GATT profiling. Okay, so we'll be doing that. Okay, so remember, you have to add here some communication technology, connectivity. Once you add a connectivity, now this board or a node can connect to a network. For example, you have added Wi-Fi. Okay, once you add a Wi-Fi, now it can talk to a Wi-Fi router. Okay, now it can connect to a Wi-Fi router. Suppose you are connected to Wi-Fi router here, or some modem, or some Wi-Fi hotspot. Okay, so this is Wi-Fi client and this is a Wi-Fi station. So this Wi-Fi client connects to this Wi-Fi station, that is a router and a hotspot. Once it connects, now your node gets internet access. Okay, node is having now internet access. Okay, so because Wi-Fi, remember, without network, internet also we can have a connectivity. Once it is connected, it can work locally, but if you want to send data to some cloud or an online server, then in such case, you have to connect your device to the internet. So it requires internet access. Okay, once you have your node is having internet access, now the thing is we have to send data from node to the cloud. So data will be transferred from node to the cloud. Okay, how to transfer data from node to the cloud once it is having internet access? Any idea? How to send data from node to the cloud? So we are getting, data is collected at the node, but we want to transfer the data from node to the cloud. Okay, so basically there are data communication protocols we need to use to transfer data. Okay, so data communication protocol. So data is transferred from here to the cloud. Okay, so here suppose you have the cloud. So to the cloud or local server. Okay, so data is available here. So how to transfer data from here to here? So data communication protocol HTTP, or you can use MQTT, or you can use COAP. Okay, basically MQTT is famous, and most of the clouds supports MQTT. So HTTP and MQTT, most of the clouds like IBM, IoT Cloud, and Azure IoT, AWS IoT, and there are other clouds like Google IoT, ThingWorks. Okay, all these platforms generally supports both HTTP and MQTT for data transfer. Okay, so HTTP, all of you know about this HTTP. This is for web communication. MQTT is mainly for IoT communication. We call it as a M2M protocol, machine-to-machine communication protocol. Okay, right. So now data is being transferred from node to the network. Through the network, we are sending this to the cloud. Once data is available in the cloud, you can do many things. Okay, so you can create an app and you can display data here. Or you can send SMS notifications, or you can send WhatsApp messages from here, or you can actually do some analytics here. So today the cloud supports not just data storage, more than that. Okay, so you can actually create an app and you can directly host your app within that cloud. Okay, or you can create SMS notifications, email notifications. Suppose I mostly use AWS Cloud for industry grade applications, and for our clients we generally use AWS IoT for industrial Internet of Things and automation. So in such case, this cloud supports many things like SMS, email notifications, push notifications, and app. So there are other things also, like it has its own databases, but some services are costly, and we should see the cost of the service, and based on that we have to choose. But the most reliable service, AWS, most reliable and fast, and it is easy for everyone to use and design products. Okay, so and it is scalable also. Okay, so easily you can scale up. So this is about the cloud. So you can visualize data. Okay, this is how generally you design IoT products. So IoT, when you say IoT, so you need to learn designing the node. That is the first step. So designing node is all about embedded systems concept. Embedded systems or embedded device concept. Okay, so networking is communication concept, and cloud is about software development, but it's not much software. It's all about understanding the tools and working with the tools. Okay, so because no one is writing big coding in clouds, right? So just drag and drop, and you may be writing small rules. Okay, you should know how to write the rules. That's it. Okay, then you can design your application. Okay, here in the cloud. But in reality, when you design app, then you have to work on front end application. Suppose you want to design some front end application, web application. Okay, in such case, yes, you have to work because it takes time. And some people, generally design Android applications, or some people try web applications using Node.js, Node JavaScript, React, Express.js, and some MongoDB database. Okay, so they use some, Marin stack to design their own, web application. But there are already existing application development environments are present. Okay, most of the industries don't develop apps because it's time consuming and it's not required for their applications. In such case, there are some services like Node-RED. Node-RED is a platform where many people directly use this Node-RED for IoT. Okay, so most of the industries like Siemens, okay, Schneider Electric, they suggest Node-RED for industrial Internet of Things applications. But working with Node-RED, basically you need to learn JavaScript. Okay, so basically JavaScript is present in this Node-RED. It is built on JavaScript. Okay, it runs on Node environment, Node JavaScript environment. Okay, so some of these terms are new to you. If these are new to you, just we'll have later on session. But here I'll be giving some brief idea about how you can make some things intelligent. Okay, this idea, this not basic level thing, but so I'll be giving you overview. Okay, so we are not going deep into any concept here. Right. So this is what exactly IoT is. So what is IoT? So IoT can be defined as things which are embedded with microcontrollers, sensors, or actuators, connectivity, and having network and cloud connectivity. Okay, so that you can remotely control things, or you can remotely monitor things, or you can make autonomous devices using that, or you can design a smarter talking devices, speaking devices using this. Okay, so it's all about you need to know these steps. Okay, designing node, working with network, cloud, and then apps. Okay, these are basic thing. Right, so thing can be anything. See, many people think that thing is only water bottle, not just water bottle. You can use phone, watches, thermostats, cars, electric meters, sensors, clothing. So clothing also. So there is a Hyderabad-based company who works in this broadcast wearables. So they combine shirts and IoT. Okay, shirts and IoT. They make shirts. Those shirts generally measures temperature, measures like number of steps walked, kilojoules burned, okay, calories burned. So all this data generally these shirts are measuring. Okay, so it depends on what is the requirement. So there are smart cars which are connected cars, smart electrical meters, smart thermostats, smart watches, smartphones, smart sensors, smart shirts, okay, smart band-aids, smart TV. Okay, so if you name anything, so all these products are today existing. Okay, so these are all IoT products, but when you add IoT to a thing, generally we call them as smart devices, basically smart things. But reality, it is not. Okay, basically these terms comes smart things. Okay, smart is intelligence, right? So you have to add another thing here, ML. Otherwise, this will not become intelligent. Okay, all of you. Right. So example here, cricket bat. You can make a cricket bat smart. Okay, so it can measure backlift angle. It can measure downswing angle, the force with which you are hitting the ball. Okay, everything this bat can measure because this bat is having an IoT device embedded. Okay, it actually transfers all the data to the app. In the app, you can see the performance. Okay, for a ball-to-ball performance can be seen in this particular app. So these are simple example for IoT device, and there are many IoT devices. But basically, you have to design IoT devices based on some problem. Okay, so remember, so connected things is not important. Okay, so unless you are solving a big problem or big issue. Okay, so and your product should be MVP, minimum viable product. Okay, so people should be able to use it. Okay, and it should solve their problem. Otherwise, designing a product is not at all useful, right? All of you. Suppose there are so many water bottles, smart water bottles existing already in the market. Maybe smart pen, smart bat, or smart ball, smart chair. Yes, there are many, right? So what you need to do is we should not see the products and inspire, but we should see the problem and inspire so that you can make difference through innovation. Right. So IoT devices generally designed mainly for three important purposes. Why people design IoT products? Any product that comes with IoT, they are basically mainly for monitoring, that is remote monitoring. Remote monitoring is a first purpose. Second purpose, some products comes under this purpose, that is remote control. And another one is autonomous, and third one is actually optimize. Okay, so these are the four important purposes generally any IoT product comes under. Okay, if you are using some IoT product, it might be monitoring remotely, or it might be for remotely controlling something, or it might be for optimizing some resources, or maybe it is for autonomous system, designing autonomous system. Okay, so remote monitoring, most of you know remote monitoring, right? So air quality monitoring, remotely monitoring air quality. Okay, by sitting at your office, you can see what is happening in your room. Okay, at your house. For example, you are staying in Vellore and your home is in some Hyderabad, and you want to see what is happening in your home. Okay, what is the temperature? What is the humidity, or what is the air quality of your room? How or what might be the healthy state of the room? Okay, you can measure that remotely by deploying some air quality environmental IoT device. You can do that. Okay, that's the remote monitoring. And remote control is all about controlling various applications. For example, if pressure goes too high, shut off the valve is an example. So you can see here there is a doorbell. Okay, it is attached to door, and it recognizes the people and opens the door, and it can do many things. It can talk to the people, okay, delivery people, and ask them, and they can scan, and they can do a lot of things. Okay, so these are the control things. Controlling is all about controlling something. So controlling some physical quantities. So you can control lighting. For example, best example is Philips Hue. So most of you know about Philips Hue. How many of you are using smart light bulbs in your home? Anyone is using a smart light bulb in your home? There are some bulbs which are under 600 rupees, 700 rupees are existing in the market, smart light bulbs. Anyone here using? You can unmute and say if you are using. Okay, right, very good. So you are using a smart bulb. Okay, good. So when you're using smart bulbs, what you do is you'll be using app. Using the app, you'll be controlling on off control. You do on off control. So that is turn on the light or turn off the light. Or you may be controlling the brightness of the light bulb, brightness control, or color control. You might be controlling the color. So these are the three things you might be doing with your app. Okay, so your app is there, and here you have bulb. So app and bulb generally connected through some Wi-Fi. So now from app you can give the commands, and light bulb will act according to. Okay, so it can produce colors, it can change the brightness, or you can turn on or turn off the light. Okay, even you can use voice to control the colors. Okay, so in my office I have all these bulbs. Okay, and we have our own home automation boards. Okay, by using voice generally we do controlling many things, or this is how generally people use. Instead of buying general light bulb, why can't you buy conventional light bulbs? Why can't you buy smart light bulbs and start using them? It gives you experience, and the same thing you can replicate in designing. You can do some reverse engineering as well. Okay, these are remote control. And then autonomy. Okay, what is the meaning of autonomy? Okay, so when you combine monitoring and controlling together, so autonomous cars. Okay, so it completely removes the human intervention. Okay, so they work on their own. So it's like, in control system subject, you learn about automatic control system. Okay, so no one will be there, so automatically it will be controlled, right? But autonomous cars or autonomous drone, autonomous robotics or collaborative robots, okay, or industrial robots in manufacturing, domains. So they generally, do many tedious jobs. Okay, generally that human beings can't do it. Okay, they do it. Okay, and they are so accurate. Okay, so and they are so secure and safe. And they are existing today. So how they are building those products? See, when you call about autonomous systems always build with IoT, embedded systems, machine learning, cloud computing. Okay, all these concepts should be used together, not just one thing. Okay, so there are many concepts generally should be combined in autonomous applications. Okay, so that is autonomous. So autonomous is important because the future is about autonomous systems, right, all of you? So basically you learn now what is IoT. You know what is IoT, so you can control anything remotely, you can monitor anything remotely, or you can combine these two things. Okay, so now artificial intelligence of things is adding AI or machine learning to your IoT product, so that you are actually giving some thinking capabilities. You are adding some brain. So far you have senses, so now you are adding brain so that it can become autonomous. It can think and make decisions. See, so far your device is not making decisions. Now your device can make decisions on its own, making decisions on its own based on IoT and ML. Okay, that's the intelligent. Okay, if it can make decisions on its own, then we can say it is intelligent, right? Then we can say that is smart. Okay, so smartness is all about adding these two, IoT and ML, together, right? So generally, see, when you design, when you control machines generally follow instructions given by you. Okay, so they don't make decisions on their own. So all the machines, when you connect, so smart light bulb also, they are not intelligent in reality. Are they intelligent? No, right? They are just following commands given by you. When you use IoT, many IoT devices today are dumb. Okay, you see there are many devices in the market. Okay, so why IoT products fails? Some products fails in the market. Why some IoT products are failing in the market? Because they just build a product, but those products are not intelligent. They are dumb products. They just follow our instructions, not more than that. Maybe you are using, instead of using switch, you are using app. Okay, so why we need to use just app instead of using switch? Both are same, right? But you are doing it remotely. Okay, fine. There is some convenience. There is a ease of use. And yes, now if you can add intelligence, then you can actually increase the credibility of the products. The product credibility can increase when you can add intelligence through machine learning, not just with IoT. Okay, so you need a machine learning or analytics or data science concepts to be combined with IoT. Okay, so I hope this concept is so clear to you now. Okay, why we are so you with this concept you can design a robot, okay, to dance like you, or to play like you, or to work like you. Okay, it can do anything. Okay, because it has IoT concept and you trained it. You trained this robot to dance, or you trained this robot to play, or you trained this robot to work along with you. Okay, so there are some robots working today. Suppose after this class you can go to KUKA robots. KUKA robots, you can see some interesting videos about these KUKA robots. And MIT also has some very good videos on robotics. So just see about them and try to understand how well we can design such robots, using IoT and ML concepts. Right. So basically, what is machine learning? So I'm not going deep into this because almost we are very near. So machine learning, we know what is a machine learning. Okay, so machine learning is simple, all of you. It's all about teaching your machine or system or software or application, so that when you train this machine should make decisions on its own. Okay, so machine learning is all about designing a system to make decisions or for predictions. Okay, so for example, the machine itself can understand and can choose or can predict. Okay, so this is going to happen, so we have to do this. Okay, so for doing this, okay, so the concept is simple. There is Stanford University definition. Okay, the science of getting computers to act without being explicitly programmed. So it's it's all about a definition, but don't see these definitions, because sometimes if you don't all the definition, it may become confusing. So what I do is machine learning is all about using data to train your machine. Use data to train machine. So how to use data to train the machine? Okay, how I can train my machine using the data, right? So here, to bridge this gap, generally ML concepts about how to train using the data. Okay, so these ML concepts generally are simple example is a regression concept. Suppose regression. Most of you know regression. Regression is a concept to predict continuous data. Okay, for example, temperature prediction, or for example, salary prediction, or suppose some air quality prediction. Okay, so regression is one technique. Okay, so it follows a simple equation y equal mx plus c. Okay, so most of y equal mx plus c is a straight line equation, or I can say this is a regression equation, simple linear regression equation. Okay, so training is all about producing some model. Remember, all of you. So training using data is all about producing some model. Okay, for those who are listening just first time about machine learning, it's all about producing some equation. Okay, so for example, you have XY data. So I'm just teaching in a very simple way. XY, okay, you have some 110, 220, 330, 440, and so on. Now you are building an equation y equal to mx, suppose. Okay, so you want to build this equation. This is a model. Okay, this is a machine learning model. Okay, so you want to build this model by using this data. So now using this data, you want to get some relationship between x and y. Okay, so there is some relationship between x and y. If there is some relationship, then only you can build a relationship between y and x, and you can get only equation if there is a relationship. Remember, all of you, in machine learning, generally we obtain relationship between input and output, basically. Okay, so you have x input and y output, and you want to get some relationship between x and y. If you want to get some relationship between x and y, there must be some correlation. Generally we call it as in statistical terms, we can call it as correlation. Okay, so there must be some correlation between x and y, otherwise we cannot get an equation. Okay, so here if you see 1 x1 and y10, 220. So from this, you can easily say what is the relationship between y and x, all of you. Y is equal to, yes, anyone can tell. Y is equal to, yes, anyone? What is m value here? Can you tell me what is m value?
Slope.
Yeah?
The slope.
Yeah, very good. So, right, very good. So we have simple data I'm showing: 110, 220, 330, 440, 550, 660, 770, 880, 990. Okay, now this is x and y. Now I want to draw an equation from this data. Okay, remember, I want to draw an equation from this data. Okay, so I want to produce an equation between these two, x and y. So that equation is suppose y equal to mx. So what must be the value of m to satisfy all these data points? If I substitute x equal to 1, then I have to get 10. If I substitute the value x equal to 2, I have to get y is so what is the m value?
10.
Right, 10x, right? So this y equal to 10x is actually called as model. It's simple linear regression model. So now suppose now your model is ready, prediction model. This is called as prediction model. Suppose this is actually input and this is the output. So equation is 10x, y equal to 10x. Suppose if you give here 100, what must be the output, all of you? What must be the y when you give x equal to 100? 1000. Right. So see, there are two steps here. One is building the model. Okay, machine learning model, getting the machine learning model. So you'll be getting the machine learning model by using some technique. Here, the technique is simple linear regression. So we got m value. Finding m value is called as solving the machine learning problem. So we got y equal 10x. Once you get y equal 10x, okay, now this is the model. Once you get the model, you can use this model for prediction. So I'll be giving some input value and I'll be getting the output value. This is called as prediction. Okay, once the equation is ready, the model is ready, you can predict. Okay, this is an example for machine learning model. Machine learning is a very simple concept, but when you go deep, it looks complex. Okay, but see, it depends on how you want to use these concepts. Okay, so based on your application, you'll be learning. Okay, because in today's society, we can't learn everything at a time. So based on our requirement, we'll be learning things. Okay, so I tell you all of you. So IoT basic concepts are required for you to become expert in smart things, product design, and ML basic concepts like you should learn supervisor learning. In supervisor learning, you should know what is classification algorithms and regression algorithms, and you should learn unsupervised learning algorithms as well. Okay, so in an IoT, at least you should know working with Arduino, Node MCU, basic, ESP32, Texas instrument boards. Okay, and then some Wi-Fi module, at least Wi-Fi module, Bluetooth, and some cellular communication boards as well. Okay, so when you have all these concepts, you can surely become very good, product developer. Okay, all of you. So this is about this program, and I'll be going ahead. So there are many products in smart, IoT products. So this is a smart intelligent product called as Saphira Smart Cooking. Okay, so what is this? Okay, some of you don't know how to cook also. Some of you knows cooking, but when you see some videos or when you are involved in some work, you used to forget that you kept something on the stove. Okay, in such case, you want to get some alarm, okay, or some notification. Okay, this smart Saphira cooking uses gas sensing mechanism. So it measures TVOC, and also it measures CO2 values, temperature values, humidity values. So generally, this is the device. This device should be kept, just near to the stove on the top, just near the stove. For example, this is a stove. Suppose you are cooking here. This is the sensor IoT device. So it collects continuously all the data: TVOC, CO2 value, temperature value, humidity value, and PM 2.5 particles. PM 10. All this data will be measured. Okay, and they use their machine learning algorithms to predict whether how much percentage cooked. For example, you started cooking here. So now, 50% cooking completed, 90% cooking completed. Now at the 90%, you'll be getting a notification that 90% cooking completed. You can go and visit your, stove, and you have to check, what is happening there. Okay, so you'll be getting all these notifications, but directly by combining IoT and ML here. So they are using that, and at the same time, it can give you the safety, cooking safety. Suppose you forgot to turn off the stove. Okay, so then you will be getting safety alerts, and you will see what is the air quality, what is the air you are breathing, what is the quality of air you are breathing. So So they actually says that they are using IoT and ML. You can go to their website and you can see Safira Sense, okay, how they are selling this product for approximately 30K and okay, all of INR, Indian rupees, okay, $400, I think, approximately. Right, so you can design such products. So this about today's program. There are many examples like voice assistants are intelligent devices. So they have IoT and ML together. You can combine learning thermostat. The people who are investing in this domain: Amazon, Nvidia, Google, SAS, Ring, Qualcomm. These are some companies who are investing in AIoT, artificial intelligence of things, and there are many other companies who are doing this. Okay, so I just mentioned few companies here, all of you. So thank you so much. I'll be finishing this now. So these are basic introductory thing. Okay, so I hope all of you are able to understand this, right?
Yes, sir. Yes, sir. Yes.
Yeah. So if you have any doubts or if you have product ideas, if you are struggling to design something, okay. Yeah. So I have a couple of industry people with me. Okay. So generally they can help us. Okay, in guidance and all. So you can contact us through the coordinators of this program. Okay, and if you have any doubts, you can approach us. Thank you so much, dear Prajwal and other team. Okay,
Yeah.
all the students here. So if you have any doubt, you can approach me. Thank you so much. Thank you. Thank you.
Sir, just a second. We'll just
Yeah.
thank Mr. Bapuji Kanaparthi for taking his precious time out and agreeing to be the speaker for tonight. We are really enlightened with your knowledge and presence. Thank you for clearing our concepts and enhancing our understanding pertaining to IoT and ML. Indeed, you have put your best efforts to make this event unforgettable. We really owe you a lot. Last but not the least, I thank all the students for attending this interesting session. I once again thank everyone for making this event a success. Thank you for joining once.
Yeah. Thank you so much, Prajwal. Yeah. Thank you all.
Thank you.